Okay, here's question number 3 on your lab, or part 3 to your simple circuit lab. With this one, we are now in series. So we have 3 series resistors, 3 light bulbs in series. They are all stamped as being 75 watts. So that's why I have 75 watts down here. However, remember that 75 watts, that stamp is with the assumption that you have 120 volts, which you do, and that they're wired in parallel, which they're not. So that's why I have them only in parentheses. They are stamped to 75 watts. We will label them as that, but they're not really going to give off 75 watts. That's the idea of this lab. Okay, so first question is, what is the voltage across a complete circuit? As always, since you're in the United States of America, you know that you have 120 volts, so A is just going to be that. 120 volts is the voltage across a complete circuit. All right, next, what is the voltage across each bulb? Because you know that they all have equal voltages across, because you know they all have the same amount of resistance, you know that these 3 will have to add up to 120, and they're going to all add up equally because they have the same amount of resistance. So you can assume that each one will have 40 volts. 120 divided by 3 means each one will be 40 volts. Okay, the next question just says, since we remember that the only thing that actually transfers the whole time in a light bulb, it's not the power, because you don't know what the voltage will be across that. The resistance will be the one thing that always stays the same. And the resistance in each one you calculated in question number 2. For 2D, you had to calculate that the resistance was 192 ohms. So for every one of these resistors, we know that the 75 watt light bulb will have a resistance of 192. So now you need to figure out the current. And the current running through each resistor will be, you just need to figure out Ohm's law. You have V equals IR, right? And if we need if we need current, that means voltage divided by resistance. V over R will give you your current. So V over R, voltage in each resistor was 40 volts. So we've just figured out that, and remembered that the resistance in those 75 watt light bulbs is 192 ohms. Divide that out, and you get 0.2083 amps going through this resistor. Because they are in series, that means every resistor will have the same current. Because you have something that is traveling through in series, no matter what, if it's going through here at 0.208 amps, there's no splitting up, there's no branches, there's no splitting up of the current. So that means everywhere in the current, everywhere in the circuit, you will have the same current of 0.2083 amps everywhere. Now you need to figure out the power of each light bulb and the actual power. So it's stamped at 75 watts, but what's the actual power? Well, you have to calculate it. P equals IV. I, we just said, was 0.2083. And we already figured out that the voltage is going to be 40. So multiply those two out to get your amp of 8.33 watts. So even though this is a 75 watt light bulb, you notice that it wasn't very dim or wasn't very bright, so it wasn't 75 watts that it was giving off. It was only giving off 8.33 watts. Okay, the next question just says, what's the current of the complete circuit? And again, if the current here is 0.2083, everywhere it has to be the same amount. There's no splitting up. There's no branches. So everywhere in a series circuit, the current will be the same. So it's still 0.2083 amps everywhere. Now the last question asks for the power of the complete circuit. And the power of the complete circuit, so the total power, is just going to be equal to the total current, which is the same thing, 0.2083 times the total voltage. The total voltage in this case is going to be 120. So you have a voltage of 120, which is the total voltage of the circuit, times, again, the power of the current of 0.2083. Multiply that out and you get 25 watts. So this entire circuit that had 375-watt light bulbs in it really is only giving off 25 watts total. All right, there you go. There's section 3 for your circuit lab.